We live in a world dominated by computers. From smartphones to smart homes, these digital brains have become an indispensable part of our lives. But have you ever stopped to wonder how these machines actually think? How do they take in information, process it, and spit out results that make sense to us? The answer lies in understanding the information processing cycle, a fundamental concept that governs how computers work. Think of it like this. Imagine a chef in a bustling kitchen. They receive raw ingredients, chop, mix, and cook them according to a recipe, and finally present a delicious meal. Similarly, a computer takes in raw data, processes it using specific instructions, and produces meaningful output. This essay will take you on a journey through the 4 key stages of this cycle: input, processing, output, and storage, drawing parallels with human decision-making along the way. Understanding this cycle is not just for tech wizards. It empowers everyone to use computers more effectively, troubleshoot problems, and appreciate the complexity behind seemingly simple tasks. It demystifies the digital world, making it less intimidating and more accessible. So let's dive into the inner workings of these electronic brains and unravel the magic of information processing. Section 2. Input, the gateway to information. The first stage of the information processing cycle is input, which is essentially the process of feeding data into the computer. This data can come from various sources such as a keyboard, mouse, scanner, microphone, or even another computer. For instance, when you type on your keyboard, each keystroke sends a signal to the computer which interprets it as a specific letter, number, or symbol. Similarly, when you click your mouse, the computer registers the coordinates of the click and performs the corresponding action. It's important to note that input isn't limited to physical devices. Computers can also receive data from software applications, online databases, and even sensors that detect environmental changes like temperature or light. These diverse input methods allow computers to gather information from the real world and translate it into a digital format that they can understand. Just like humans rely on their senses to perceive the world, computers depend on input devices to gather data. Our eyes detect light, our ears pick up sound, and our skin senses touch. Computers use cameras to capture images, microphones to record audio, and touchscreens to register physical interactions. This analogy highlights the crucial role of input in both human and computer decision-making, as it provides the raw material for subsequent processing and analysis. Section 3. Processing the engine room. Once the computer receives input, it moves to the processing stage, which is where the real magic happens. This is akin to the chef taking the raw ingredients and transforming them into a delectable dish. During processing, the computer's central processing unit, CPU, acts as the master chef, executing instructions from software programs to manipulate the data. These instructions can involve performing calculations, sorting information, comparing values, and much more. For example, when you open a spreadsheet and enter some numbers, the CPU follows instructions from the spreadsheet software to add, subtract, multiply, or divide those numbers. Similarly, when you search for something on the internet, the CPU executes instructions from the search engine software to sift through vast amounts of data and display relevant results. The CPU is like the brain of the computer, responsible for making sense of the input and transforming it into something meaningful. Just as our brains process sensory information to make decisions and take action, the CPU processes data to produce output that aligns with the user's intent. The complexity of processing tasks can range from simple arithmetic to sophisticated artificial intelligence algorithms, highlighting the versatility of this stage in the information processing cycle. Section 4. Output, making sense of it all. After the data has been processed, the computer needs to present the results in a way that humans can understand. This is where the output stage comes in, which involves displaying the processed information on a screen, printing it on paper, or transmitting it to another device. In essence, output is the culmination of the chef's efforts, presenting the finished meal to the diner. For instance, when you write a document on your computer, the output stage involves displaying the text on your screen and allowing you to edit it. Similarly, when you play a video game, the output stage involves rendering the graphics, playing the sound effects, and displaying the game's interface. These various output methods allow computers to communicate with humans and share the results of their processing. Just as humans express their thoughts and feelings through speech, writing, and body language, computers use output devices to convey the results of their processing. Our vocal cords produce sound, our hands write words, and our facial expressions convey emotions. Computers use speakers to play audio, printers to produce text and images, and screens to display visual information. This parallel emphasizes how output bridges the gap between the digital and human world, making computer processing accessible and understandable. Section 5. Storage memory lane. The final stage of the information processing cycle is storage, which involves saving the data for future use. This is like the chef storing leftovers in the refrigerator for later consumption. Computers store data in various forms such as hard drives, solid-state drives, USB flash drives, and even online cloud storage services. For example, when you save a document on your computer, the data is written to your hard drive or solid-state drive. Similarly, when you download a file from the internet, the data is stored on your device for later access. This storage capability allows computers to retain information and retrieve it whenever needed, enabling long-term data management and retrieval. Just as humans rely on memories to learn from past experiences and make informed decisions, computers depend on storage to access previously processed information and build upon existing knowledge. Our brains store memories, experiences, and learned information, allowing us to recall and apply this knowledge in different situations. Computers use storage devices to archive data, access historical records, and retrieve past computations, enabling them to perform tasks based on accumulated information. This analogy highlights the importance of storage in both human and computer contexts, as it provides a repository of information that informs future actions and decisions. Section 6. Conclusion, appreciation for the digital age. The information processing cycle is the invisible engine that drives the digital world. By understanding its 4 stages, input, processing, output, and storage, we gain a deeper appreciation for how computers work and how they interact with us. We begin to see the complexity behind seemingly simple tasks, from typing a document to browsing the internet. This knowledge empowers us to use technology more effectively, troubleshoot problems, and make informed decisions about our digital lives. It also fosters a sense of wonder for the ingenuity of computer science and the transformative power of technology. So the next time you use a computer, take a moment to appreciate the intricate dance of information processing that makes it all possible.